Good morning students, I am Govind Vyas from Cambridge Convent School, Bikaner. As you know, in our previous lecture, so far we have conducted 2 lectures. Out of them, now we are going to discuss these particular topics. Still we have completed the work segment of our chapter Work, Energy and Power. Today we are going to start a totally fresh topic, energy. We shall study in this lecture definition of energy, some regular life examples of energy and unit of energy, means in what unit energy is calculated. Clear? So firstly we are going for the definition or fundamental concept of energy. The definition of energy is the capacity to do work is called energy. The capacity to do work is called energy. You can understand this by correlating it with the work. Like in the first lecture, I told you about work. When the force is applied on an object, then it covers some displacement, right? Okay. Take one condition. I am applying so much force with the help of my body on this wall, but can I move this? I cannot move this. There is force, huge amount of force, but distance is not being covered. That means there is not work. Work is force into distance, right? I am applying force on this wall, I am applying force, but distance is not being covered. This is 0. Suppose that I am applying a force of 100 Newton, but distance is 0. What is 100 into 0? Ultimately, the work is 0, right? This is our concept. But if work is not happening, in spite of it, why I am feeling tired after I try to push the wall? I feel tired. I feel tired. When I push this wall, work is not happening, that is sure. But why I am feeling tired then? Because something has just gone out of my body when I was trying to push this wall. What was that something? That was energy. Clear? I did not invest work on pushing the wall. I invested energy. I tried to apply work, or I can say I applied energy of my body on this wall. Clear? Fine. So basically the capacity to do work is called energy. Fine. This is the definition. Okay. Now regular life examples of energy. We see energy in everyday life at lots of places. Like we humans, living organisms, require energy to execute our works, like walking, doing some work, like I am speaking. This also requires energy. So where does we get this energy from? We get this energy from in form of food. Food is the form of energy we humans use. In the morning I have taken my food, so now I have energy enough to deliver you the lecture, right? Okay. But when I am continue speaking, when I am continue delivering the lecture, after some time the energy is getting decreased. That's clear? Okay. When the energy gets decreased, I start feeling tired. Then what happens? I require now more energy. Then what will I do? I will consume the food again in the evening, and then I will be charged. I will have energy again to execute my other works. Clear? So we get energy in form of food. So this can be one example. We always require some input energy so that we can do some output by this. Machines require energy. Anything which does work requires always energy. Like talking about machines, take machines like automobiles, our vehicles. When they are moving, they require some energy so that they can do their work. How will a automobile or a vehicle move if we do not give it energy in form of fuel, petrol or diesel or gas like CNG? We give them energy in form of fuels. Clear? Fuel energy is given to them, that is why they are able to run. Okay. Now, other than that, take very extremely easy example you used to in your childhood. You had a toy car. There was a toy car having wheels. What we used to do, we had a key of the toy car. There was a hole at the near the rear wheels, and we used to round the key into the car. Then what used to happen? After completely rotating the key, we used to leave the car on the ground, and it used to start moving, right? We invested, we gave the car some energy, and now it's ready to move. Until what time it will move? Until its energy gets completely be utilized. After its energy is utilized, it will stop again. Now it requires energy to move. We shall use it and give it energy in form of rotating the keys. Clear? So there are energy in everywhere around us. Clear? Fine. Now we are trying to study what is the unit of energy. What is the unit of energy? Energy is always measured in joules. Joules, or it is denoted by capital J. Energy is always measured in joules. 10 joule of energy, 20 joule of energy, 50 joules of energy, 100 joules of energy, 2 kilojoule of energy. Clear? So energy is always measured in joules. Joule is the unit of energy. Now there must be a conflict in your mind that in the previous lecture I told you that work is measured in joules. Now I am telling energy is also measured in joules. What is this conflict? Because energy and work can be converted into each other. We will write here work and energy are mutually convertible. Clear? Work and energy are mutually convertible. Work can be converted into energy, and energy can be converted back into work. It is same like ice and water. You can convert ice and ice into water and vice versa. Clear? So same thing. They are same thing but in different forms. Same thing goes with work and energy. They are same thing but in different forms. Clear? Work can be converted into energy, and energy can be converted into work. Let me give you some examples. Like you have fuel in your scooty or bike, whatever you use. Fuel is a type of chemical energy. It is an energy. Fuel is a chemical. Okay. But when you run your vehicle, then what happens? That energy, the fuel gets combusted. The fuel gets burned. What happens? The energy is being converted into work. What work? Your bike is moving. You are applying some force with the help of your accelerator, and your bike is covering some distance, so work is happening there. Okay, so energy of the fuel is being converted into moving the bike, in short, work. Clear? And this is the example of energy being converted into work. What about the vice versa? That means work being converted into energy. Suppose that I am running very fast. So I am applying some force with the help of my muscles, and I am covering some distance. Force is being applied and I am covering some distance. So force is there, distance is there. That means I am doing some work, right? Because work is always force into distance, and I am doing the both. So I am doing work. What happens after I stop? I feel that the temperature of my body has just increased. Now I feel little bit heated inside me. So what is that? Heat is also a type of energy. When I did my work of running, then my body just increased its temperature, or I can say that work was converted into heat energy. Clear or not? So while I am running, the work is converted into energy. So this is the example of work being converted into energy. Fine. So this statement, I hope it is clear to you that work and energy are mutually convertible. Because we can convert them into each other, so we can say that they are the same thing. They are almost the same thing. Because they are the same thing, so they can be measured into same unit. Work can be measured into joule, and same goes for the energy. I hope you are clear with this. Fine. So this is enough for today's lecture, and in the coming lectures we shall go for the types of energy. There are some numericals, derivations, and many more. We shall discuss them. So till then, like this channel, share and subscribe. Okay, thank you.